All right, welcome back, everyone. This is stream number 2 for PS, where we just write software together. And I say we because you can participate in the design and what we do along the way. And what I'll try and do, I'll essentially be implementing things, and you can submit questions, feedback, suggestions for how we should be designing our software as we go. And if you want me to cover some other topic like web development, etc., anything, just let me know in the feedback. So if you scroll to the bottom of this Twitch page, there should be a link to a forum where you can submit feedback. Any questions as well. Great. So here's our stream log, right? We'll use this document to kind of record everything, all the questions we're answering, and also to set goals at the beginning of each session. So for this session, I want to continue working on re3, which is the regular expression library. But today I wanted to, instead of doing any coding necessarily, any project setup, I wanted to dive deeper into how we're going to design re3 instead. So normally we kind of decided the interface pretty well yesterday. We set up the build properly to use CMake, and then we can cd to use CMake. We can create a build directory and just CMake the previous one, and it'll do everything we wanted. So we decided interface. We had some implementation details, but more than that. Hold on one second. Right. More than that, I wanted to dive deeper into exploring some of the questions we left unanswered in our design doc. Right. So here is the design doc we started forming yesterday, and I'm going to try and fix it top down. Right. So I'm going to start in the overview, go into the requirements, usage, and then etc. And just sweat out all the details essentially before we get into writing. Because what I've done is I've done that thing where you kind of dive into writing code, and what ends up happening in those situations is there's an unforeseen dependency, and that ends up breaking the code that you had before, and you start shuffling things, you try to git revert back, and I just don't want to deal with that. And what design docs are particularly good at is they communicate a design, and they also do a pretty good job of anticipating dependencies as they come. If there is an unforeseen dependency later on, the risk of that happening is lower and the damage is controlled a lot better. Because you can force yourself to decouple dependencies as you're making a library or any project that you're doing. So yeah, re3. So re3 will be a regular expression library that aims to be fast. That can be a little bit more specific. So instead of saying a future tense statement like this, we can say what re3 is now as if it were implemented. re3 is a fast. What else would we want this to be? Ideally, we would want this to work in a fast production environment. So most production software today is multi-threaded, so we can make it thread safe, I guess. Fast, thread safe. We'll just have this umbrella term for production ready, right? Production ready regular expression library. The aim of it is you can take a regex and compile it and use it quickly and get rid of it quickly. I guess we can add memory efficient to this. Efficient as well. Kind of generic terms, but we can quantify those vis-a-vis the inspiration for this library, which is re2. So that's this overview. Now this is incomplete, and the reason you know it's incomplete is it's a single sentence. Ideally, an overview should probably contain what should people be able to do with this library. Before I get into that, there's something that I realized yesterday, as I was after the stream, which was requirements shouldn't really be requirements should be exactly what they are, requirements. Like this library is required to do this to meet some kind of business need. But faster than re2 is more of a goal, not a business need. So we're going to move this into our overview as a goal. Yeah. Goal. So we'll just say specifically the key metric for speed and efficiency will be the re2 library. And then we can add the link. Right. That's not a requirement. That's just a goal. But I want this library to be accessible to people who don't have who don't necessarily have like the same. I want anyone to be able to contribute to this, and because everyone uses different operating systems, this should work with all of them. I think that's what C make pretty good at. This should work with any programming language, and what I mean by this is what the manifestation. So re3 as a library should generate a regex runner essentially. This is a requirement we didn't explore enough yesterday, which we can do today. Just do quickly. Right. Yeah, should work with any programming language. Now this one, supporting UTF-8 char set, that's super important because we want a more expanded set of characters. We want to support a lot of characters that ASCII obviously wouldn't cover because it's a bit backwards, or it's rather old, not backwards. And the way we can do the UTF-8 with C++ is C++11 introduced UTF-8 encoding. So I believe you can do string s is equal to u and then define the string itself, and then that will encode the string this as a UTF-8 in the UTF-8 character set. That's how we will support that, so that it can support multiple languages. Some other requirements that we absolutely need for this library, which is so we want this to be thread safe, right? That's one of the things we said should be thread safe. Thread safe. And by thread safety, I mean you can use the complicated part here would be the runner itself, because that would be shared code amongst all the regular expression objects. Ideally, if you have two separate threads that use the same regex object, it should work for both. Yeah. Yeah, Zader, they are. So Zader, one of the viewers, commented that the stream's noise filters are a lot better. I realized yesterday when I was watching this that it was a bit ringy. Like if I pressed D, you would hear like a ring at the end of it, and that was weird. That was weird and annoying. But I added noise filters today, and it should be working. Yeah. And actually, Zader suggested that too, so thanks to him. Yeah. So now we're talking about what are the core requirements our library should have. This is different from goals, which is what we ideally will have, which is this, right? The key. So it should be thread safe. It should work both on Windows and Linux. It should work on any programming language. Yeah, and it should support the UTF-8 character set. If more requirements end up showing up later, we can just we can use those later. Requirements. I think that's it for requirements then for now. The usage example. I think this is fine. I believe there's a tool. Let's see. code block. Yeah, you can do this. Make it look code. Let me make this C++. Not. Oh, CPP, there it is. Yeah. Yeah, so this would be an example of how we use it. We'll describe this as, we'll do library interface here, just to reorganize this. We want to make this normal, not large. So we can move this usage example down here to make it a little bit more clear. Get rid of this. This is very... So this would be an example of... What would this be an example of? This would be an example of pre-compiling and full match. We can just move that for the pre-compiling. Right. Okay. So an example of this would be, we do if, and then re3 full match, and then we can pass a regular expression like hello, and then pass in the string of interest, that, and we'll do something here. Do full match. An example of it is above. Say that.
Better shut up.
So by this, and reuse it. Example being this. Example. We should give a more concrete example than just example above. So here we'll have, we'll actually just reuse that example. So if we do re3, this should be if we do re3 regex is low. And then what this should do is, and then we do standard string. We declare it equal to hello/n. And we'll declare this as 1 or as pass. Then declare string as 1 pass equal to hello world instead. Just to make this a bit simpler, we'll just do this. And if regex full match pass, do this. If and then we'll specify what it should print actually. This should only pass 1 because hello world entire string does not doesn't entire string does not match the regex below. Here, we'll just replicate that example, and then here we'll say both should print. Print pass2 hello world contains hello as well. Here, example. So if we have code examples, it will help us reason about the implementation under review. So here we'll have regex re3 with a string. Standard string equals my friend. Also say capture. We'll declare a capture here equal an empty string if regex.full match s. And here, because it'll contain a variable number of arguments, we'll pass in capture as a reference. If this is true, print capture. We printf string formatting. And then we'll do capture.c and do this instead of this. The last word. And this one, I think, this one describes it pretty well. You can have just this description in place. Yeah. Another goal I just realized we should have is we should describe what other things it should support. So, like, for example, what kind of syntax? So, re3 will have a Perl regular expression syntax. Now, the reason I choose Perl is because it has a lot of nice, like, character classes, and that makes the capture interface a little bit. I'm sure other languages have it too. It's just I'm used to the Perl one anyway. Yeah, let's format these. Format pass here. Good, good, good. Here we'll have this. Right now, our design doc looks a lot more readable. It's good. Okay. So that's the interface, right? Things that people should be able to do. I guess we can, this is the library features, right? Then we can have a separate section for implementation, library. So we'll just name this implementation interface. Let's just name it features. So we had a bunch of notes before that we had here in our actual folder, re3. We have it here. Keep this on this side and then get to finishing up our doc. Here, what are some things we noted that we didn't think about yesterday? Here we can have interface. We can have, just copy this, right? And as we're copying and pasting each portion, we'll think about things we haven't gotten to yet. So one thing we didn't get to, if we wanted to disallow default constructors, I think there might be something. I have a hunch that something's wrong with that, because if we explicitly disallow it, someone default constructs it. Let me just look up what cases should default constructors. So we'll actually look up disallow default constructor. This will I'm pretty sure recommend the delete. Yeah. Okay. I guess it's not that. I guess it's not that dangerous unless. Oh, so Abseil, I'm pretty sure, is the Google C++ library. So we'll see. They have to say. So if we declare our default constructor is deleted, it will still generate it will still define it, but it will define it as a deleted function instead. That's something we should worry about, right? If we want this to be in a production environment, we don't want it to fail necessarily. Or maybe someone default constructed it, it should fail. That's an improper use of it. Default constructor. Yeah, I think that's okay. We just call it a deleted constructor. Yeah. There should never be a case where you don't call it with a regular expression. It's kind of... And there should never be a case where the string, if for example a regular expression was accidentally copied, well, in that case we would call the copy constructor, which we can worry about. So I think this delete's okay. This is our actual constructor that we can use. So the next decision is to allow a delete constructor, a copy, and so we want to decide if people should be allowed to assign or copy a regular expression into another. Okay, so if someone, I guess an example of that would be kind of like a thread pool where like you pre-allocate a bunch of threads and you use those, use that set of threads you create. I guess someone could hypothetically create a pool of regular expressions. Would that make sense? No, each regular expression would be unique. Oh, but I guess, yeah, so each one would be unique, right? Because each thread isn't necessarily like compiled when it's constructed, right? It's given like an ID, it's given a context buffer, like a thread control block. Can we say the same for a regular expression? The constructor for a regular expression does a lot of work. So the state between them is almost unique to each, right? If we're trying to generate a new regular expression, we would just generate an entirely new finite automata. So we shouldn't be, I don't think we should allow for copying and assignment. Let's see how to do with move semantics. Disable copy assignment semantics. Move semantics is a domain that I am completely unsure about. So I'm gonna look this up for now. So we're gonna add a comment here. Instead of saying constructors, because it's kind of redundant, we'll say default constructor disabled to ensure a regular expression is always provided. Now delete constructor. Would we need that? We would need that if the state that we have per regular expression is something that needs to be deleted, but in this case I don't think we need an explicit delete constructor. Right, because a state table is just an alias for a vector of strings, and you can just call their destructors. I think the default destructor should be fine here. But in the case where we would have some kind of like dynamic memory, in that case, we probably need to do something. But for now, we won't. So we will not allow us. Let's move these down so it's clear to the user that this is the main constructor. So there's re3 constructor from a copy, so we do re3 as well. We reference other should equal delete. Three, actually, 3 reference. Operator equal reference. Oh no, we don't need reference. Reference. Delete. Yeah, this is where move semantics kick in. So this reference, this is not a reference to a reference. This is an R value reference. That's something I didn't understand until like a few days ago. An R value reference. So an L value is historically a value that appears on the left side of an assignment. An R value is historically on the right. So an example, an L value would be like a variable. So if you did x equals 2 plus 1, 3 would be the R value, and x would be the L value. But that's not that like assignment isn't necessarily strict, right? Because x can also be on the right side. In that case, I believe an R value reference is a reference to an R value. But I don't necessarily know too much about that yet, but I will try and find that out in the next few days. And I'll write a blog post about it as a follow-up. Yeah. But for now, we'll just disable any copy move semantics. So we have re3 reference. Now do an re3 reference here. So this would disable the copy constructor, the move via copy. So now this move should be the same interface. We don't even need to name it. Yes. Just to be consistent, let's get rid of this. All right. Great, yeah. That should be that. And then I think the rest of this, oh, we also have to find out how to do variable arguments in C++. Okay. Probably shouldn't, and probably do what you can. Oh, okay. Something C++ introduced. Variable. Okay. You can use these arguments as the format. Declare a variadic function and ellipse is used as a last parameter. Okay. Okay, so I guess args the next and then casts it. E. Okay, yeah, that's what. So we can do cast it as a here. See what this is. Set, and then we periodic arguments require errors. Really the case? So? Oh yeah. Oh. Okay. Cool. So that will be this interface, right? Copy that again. Oh. So I realize matching with catching, this will give us capture. Well, should we support capturing for I think we can. What does VA list tell us? VA list can tell us the size, object types in holding. So here we have args. So incremental search should also support matching. Now should these matching. Guess we could have methods for full matching with and without cap. With capture. By default, it won't. Is there a better way to do that though? The VH start void. Seeing the first variable. This initializer list might be an alternative to using the variadic function in your initializer list. So can we initial? The question now is, can we construct an initializer list with a bunch of pointers? guess we should specify. Lot of detail. My class pointer. Other returns initialized by occupied. I guess we can pass initializer. Instead of this periodic argument, see what library would we need? Initialize. It's needed, and then we can here, instead of passing ellipses, a standard initializer list of standard string pointers. And then we can go through one by one and just initialize each. Okay. So I think we can do that with full match. So an initializer list, number of elements in the initializer. Oh, okay. So I guess we can have the default equal empty, right? Have the default being empty, and then if it's empty, then we don't need. Huh. Okay. In that case, we don't even need these interfaces. We'll have empty. Okay. Alright. We can do this. I believe this will allow us to, in the case where they don't pass anything, I believe this should be empty. Yes, if they don't pass in anything, this should be by default empty, and then we can check the size of captures when we actually write it. So we should, okay, that's great. That actually simplifies everything a little bit. Well, the interface a little bit. Here, we want to pass. Have the string we want to match. Right. We'll go to the next string, and then here we'll say standard initializer list of standard string pointers. Captures equal to this. And here, instead of just passing in these, also pass in captures. Okay. We wanted to just move. Could we just pass it in as an argument to that? That would actually copy each of those references. See how actually just pass it by. let's look up, we'll keep that documentation up. Let's look up pass initializer list by counts ref. Okay, this question's good because it's cheap. Okay, it's a thin wrapper. Oh, sweet. Okay, so we can just pass it by value. That's no harm, no. Here we'll actually specify. Actually, that should probably be a class level comment. Great. Static find. Great. That's an awesome captures. Awesome. So we simplified our interface a little bit with the discovery of initializer lists. Just make sure our design doc. Yeah. And then we'll just trying to clear the formatting on this line. Here. Construct a regex to use re3. Can we construct the interface implementation? We should investigate how do we ensure this regular expression gets encoded as UTF-8. Yeah. UTF-8 support. Okay, I guess I was wrong about. Huh. Great. Now we're trying to evaluate whether. So I originally thought standard string came with Unicode support, but judging from these Stack Overflow posts, I guess not. Okay. Okay. It's possible C++. This is a bit of a disappointment, but all right. It's another step in our project. Oh, okay. So it does. Rostering literal. That's what I thought. Okay. So semantics. Okay. So I think we're good. And then if you specify U8, UTF-8 encoding, all right, great. Bit of a scare, but we're good. All right. UTF-8 is supported in these post searches. So now we want to make sure that the string we're getting is UTF-8 encoded. So that means that so look up how to pass encoded strings. Plan on passing the respective units. Oh, this is someone else's. Oh. So encoding conversions of SQL string. Okay. Okay. Try it again. Hmm. Wide string convert for ET. Possible that not that easy to convert TF8 properly. Standard string. Code. I'll just store it as a bunch of bytes. So you can encode it this way. This is what it would look like as a result. So we can take a string and convert it to a UTF-8 string. There's never really, I guess there's not really a case to do it the other way. I guess we can just define two functions that conversion. Maybe. C plus. Oh my god. We can prefix a string U8 encode it as UTF-8, and we can use WString convert to convert between them. Look at wide string convert. Handles things for us. Hmm. Ooh. That's also, oh, that's something we also have to consider, that Windows has a bunch of encoding that we can't necessarily just assume UTF-8 would work on it. Makes things a lot more, that UTF-8 would just be a question of optic. So what's possible is that we'll have to write a smaller UTF-8 sub-library inside to handle UTF-8 conversions, depending on if like the Microsoft compiler or like C compiler, like a Linux-based GCC compiler, compile different binaries, different libraries to handle UTF-8 conversions. Now, I also, if you're thinking, hey, Samir, you just saw UTF-8 libraries, I don't just want to copy another library, mainly because a lot of what we'll do here is for learning purposes, and I think it would be way more interesting to just write the UTF-8 library ourselves so that we can learn a lot more about it, rather than just do something else. I just also realized that if we just encoded it as a standard string, if we encoded UTF-8 string and we indexed it, we would just get a byte and not an actual readable character. So our regular expression library would also be like the initial stage of converting a regex into the symbols that it is also a lot more complicated now. Okay, so in that case, we can do a little bit more work for UTF-8 characters. So I guess we can have a separate. So instead of using standard string, we can try and say dependency. We'll have a dependency section that will specify UTF-8 string library. A wrapper to standard string that supports the UTF-8 character set. So any place where we use standard string, we should probably replace it with re3 string. So let's do a find and replace. Replace find any instance of standard string. Then we'll replace it with re3 string. And we'll use the scope re3, so it'll be between two namespaces to help us properly use our string library instead of. Right. We're gonna have to do a little bit more research into that, but I think we'll leave that for tomorrow. You have to go now. Thanks everyone for joining in, and then let's see if anyone's asked a question yet. Need any? Okay, so no one's asked a question yet. That's okay. So Sunday is usually I'll take a break, but I will be back Monday. But instead of the normal library work that we'll do, we'll instead do some algorithm practice. Now, why algorithm practice? It's because I'm not good at it. That's literally the only reason. I think being able to identify what data structure and the algorithms you need for it is super. It's obviously a very important skill, but the choice of a data structure is probably the most important choice you'll make in a program. and that's because you want to make sure that if you're writing something like a memory intensive application, you don't want the data moving so much, right? And then what a good choice of a data structure will do is it will help ensure that the choice you make will only move data when you absolutely need it, or be close to that at least. So like an example would be proper sorting algorithm. You're doing a bunch of moves that you don't need to, or a bunch of swaps, right? If, for example, if you're using bubble sort, but in a certain application, right, you don't want to do that kind of like moving because you're constrained with your compute resources. And a data structure choice and algorithm choice both define what a program is and whether it can be efficient and productive. So that's what Monday and Tuesday will be about. We'll probably do some US ACO training, or leak code or something. I don't know. We'll see then, but it's probably US ACO. Yeah. Thanks, y'all. See you Monday.